Thanks for being here, despite being the last talk of the conference and having a quite interesting speaker in the other slots as well. So I'm Björn. I'm a production engineer at SoundCloud. I also have a past as a site reliability engineer at Google, which might or might not have had an impact on this talk. Profiling for dev, monitoring is for ops, no more. It's kind of a cheesy title or philosophical one, if you want. For my standards, this is probably a pretty much philosophical talk. Usually when I give a talk, I talk about technical things like a clicker that doesn't work. Let's see. Okay. There it works. Okay. So, Prometheus, my t-shirt gives it away. I'm one of the Prometheus contributors, and usually I talk a lot about Prometheus and a lot about technical details. But this time, I wanted to talk more about high-level things, not necessarily just Prometheus. Prometheus will be a case study on example. I assumed you already know. If you see that logo, you know it's Prometheus, and you know that Prometheus is a monitoring system, right? Like not the Titan from Greek mythology, and not that beautiful, horrible movie. So everybody knows what Prometheus is, right? Okay, I hope so. It's kind of a hipster monitoring system at the moment. The idea for this talk came from a question, and I got asked this question quite often, especially in the context of this conference. Is Prometheus a DevOps tool? I guess, good question. This conference is called DevOps Con, but what is DevOps? It's kind of vague, so can I even answer the question if Prometheus is a DevOps tool? There's at least a symbiotic relationship between this conference and Prometheus, because the very first instance of this conference was 2015 here in Berlin, DevOps.con, first time ever, and there was a Prometheus talk given by Julius Volz and myself, and this was the first conference talk about Prometheus in Germany. And it was only the second conference talk globally given about Prometheus. So pretty good, right? Then we skipped Munich for some reason, I guess because Prometheus is kind of born in Berlin. So Berlin 2016, we had the Prometheus talk with Fabian, another Prometheus developer, and myself. And now it's 2017, it's only me on the stage now. And it's still about Prometheus, I guess. So what was the first conference talk that Prometheus was talked about? Was SRE-Con in Dublin. And there we are, SRE DevOps. Quite interesting, perfect segue. So what is SRE? Some people don't know what SRE is, site reliability engineering. That was kind of proprietary to Google, but not too long ago, this nice book was published. Of course, I'm totally biased because I know 80% of the people who wrote that book. Niall Murphy here, he was my last boss I had at Google. And of course, confirmation bias. What they write in the book is exactly what I believe in. But still, I think it's a really nice tech book. If you haven't read it, that's my recommendation. It's anyway pretty popular. If you look at like rankings on Amazon, you can see that. It's freely available as an HTML version, so you don't even have to buy it unless you like paper books. Read them where you don't have electronic devices. So now, what does that have to do with Prometheus? Prometheus was created by a bunch of ex-Google SREs back at SoundCloud in 2012, 2013. I joined them not from the beginning, but yeah, that's a different story. So you can totally see that. Oh, how did that even happen, right? So people left Google, they had their tooling, they knew at Google, and then they went back into the world of the mere mortals, and they missed certain tools, obviously. And so there are some tools around where people just recreated something in the spirit they knew from their former employee, or Google has open sourced something. So Prometheus is definitely built in the spirit of how Google runs large-scale production system. So I can answer the question if Prometheus is an SRE tool. The answer is yes, obviously. If you read chapter 10 in this book, you will totally see, I mean, they don't describe Prometheus, but they describe something that is very similar in spirit. So does that make Prometheus a DevOps tool? Interesting question. How does SRE relate to DevOps? I think they discussed it in the book. They might also have discussed it in some previous version, which I proofread. But like, it's definitely an interesting question. And so let's think about this just for a moment, right? SRE is definitely the older term, probably created around 2000. I joined Google in 2006, which feels like eternally ago, and SRE was already firmly established in the Google universe. So people knew what it means, what they do, and everything. So it was there, right? DevOps didn't even exist back then. Like late 2000s, this term was coined. And while SRE was, as said, until recently kind of proprietary to Google, DevOps was created in the open, was also intentionally vague. So I heard that the people who created the term DevOps are actually quite happy that people have different ideas what DevOps actually means. It's like vague by design. SRE, kind of some companies copied that concept under a different name, or they used the same name but did something different, or sometimes they even used the name and did something similar, whatever, right? Now we have a codified truth in that book, what SRE means. And DevOps can mean so many things that there's certainly an overlap. But in my view, if you take the center of gravity of all those ideas of DevOps, SRE is totally not DevOps. Some aspects are really contrary to DevOps, right? Where you can say SRE is really anti-DevOps sometimes. The interesting thing about this, without going deeper into the philosophical debate here, that despite this kind of only partial overlap, there are a lot of things that both areas can learn from each other. Like my work as an SRE gave me a lot of inspiration how I do something I would call DevOps at SoundCloud. If you read the book, there are so many things that my and your day-to-day work can totally profit from. Gives you a lot of inspiration. So coming back to the question, Prometheus, is it a DevOps tool? I would say yes. With all heart and soul, it's a DevOps tool. Which brings us back to the title of the talk, because I want to illustrate a certain aspect where you can nicely see this whole dev and ops relationship and how this is kind of DevOps in a way. And I want to look at two things, which is profiling and monitoring. Now, some people might say monitoring in the wider sense includes profiling. So what I mean by monitoring is like systems monitoring, metrics-based monitoring of your large-scale distributed services, right? And profiling is what you usually do as a developer to just find where's my CPU burned, where's my memory burned, and you find the hotspots and want to optimize your software. And obviously, profiling is what the devs do, and monitoring is what the ops do, right? Okay. Now, I want to look at both of these things from a googly perspective in a way. And Prometheus is obviously the thing that is built in a Google SRE spirit for monitoring. And for profiling, as a representative, I take the Go programming language. Go programming language, as you know, created by Google, had quite a raving success as a language for infrastructure software. And a lot of the way Google works is distilled into the language. Like if you look how it works and you know how Google works internally, you can totally see, yes, I can see why they created the language in that way. So we will look at both areas. And Prometheus, you might know it already, is written in Go. So you can already see where we will complete the circle in the end of the talk. Let's start with monitoring, not with profiling. And to be more precise, let's start with alerting, and let's start where alerting has to start in a modern, distributed, large-scale, resilient, microservice, all the buzzwords world, right? So the only way you can do meaningful alerting is symptom-based. And I mean alert as in page. You wake somebody up. In the traditional world, if something went wrong, you have a cause of something, like the server doesn't ping anymore and my Apache runs on it and Apache runs my site. If the server doesn't ping, I have a problem, page somebody has to reboot the server, right? Now you have 1,000 servers or even virtual machines or something. One is always down, and that's kind of horrible, but your systems are designed to tolerate that. So it's fine if like 10 servers are down of your 1,000, that's pretty good, actually. So you shouldn't wake up people all the time because 10 servers are down. So a server being down, or single instance being down, or something being weird, these are all possible causes, but they should not wake somebody up if it doesn't affect your user experience. I mean, user could be anybody. You could do a service to another team in a larger organization, whatever. Let's see this user as a very general term. If your user experience is affected, it's a symptom, and then you want to wake somebody up because apparently the machines couldn't figure it out, so you need human help, and that's a page. Causes is creating something I would call tickets here. Some people call it warning alerts. This is something that is still important to look after, but definitely not outside of your working hours. So chapter 6 of the SRE book has a lot about all of this. So totally read it, good read. Symptom-based alerting, very, very important. So now, monitoring, right? Symptom-based. How do we do this? This is kind of funny, because if you have ever heard anything about Prometheus, you probably have heard us brag about Prometheus is crucial for modern service monitoring, and you can't get around it, and it's a white box monitoring system, predominantly. I mean, it's not quite as pure, but yeah. But then you think symptom-based alerting, how do I find out if I'm up and I'm serving fine? Usually you send probes, right? This is black box monitoring. You probe your site with a probe from the outside. Your software doesn't even have to know about it. Black box monitoring, pretty much what good old Nagios is doing. So we were chastising Nagios and saying, this is old style, host-based, I don't know what monitoring, use Prometheus. And then suddenly you think, okay, black box monitoring is actually good for symptom-based alerting. This is what I want. And perhaps Nagios is the unexpected hero in the modern world, like the old guy coming along, and it's actually the hero in the story, perhaps. Also, you can totally see Nagios is something the ops people do. If you're a pure dev person, you have probably never touched Nagios. This is something the ops people set up, and they use it to find out if the site is up, right? They are not involved at all. Coding is not involved in how you set up black box monitoring. So, of course, that's not the end of the story. Otherwise, my talk would be pretty useless. So why is black box monitoring perhaps not really sufficient? I asked my holy scripture, my blue book, right? And we can read in the book. So what's written there about black box versus white box monitoring? We combine heavy use of white box monitoring with modest but critical uses of black box monitoring. The simplest way to think about black box monitoring versus white box monitoring is that black box monitoring is symptom-oriented and represents active, not predicted problems. Sounds good so far, right? Only that they still use a lot of white box monitoring. Then, for paging, black box monitoring has the key benefit of forcing discipline to only nag a human when a problem is both already ongoing and contributing to real symptoms. On the other hand, for not yet occurring but imminent problems, black box monitoring is fairly useless. Chapter 6. Okay, so what does that mean? Not yet occurring but imminent. So symptoms is kind of in a wider sense. If you know a symptom will strike in the next 10 minutes, it still counts as a page-worthy symptom, right? I mean, if you're really sure. You don't want noisy stuff like something is perhaps happening. But often, with something that is not just black box monitoring, you can actually know that something will happen if I don't call a human right now. I also have 3 other reasons formulated on this slide. My personal top 3 reasons why black box monitoring doesn't pull it off. This is my favorite example. Your probe is not real user traffic. I work for SoundCloud, so I can give you a short example. Let's say you have a track going viral. That happens all the time, right? Some rap battle or whatever, and millions of people all of a sudden want to listen to that one track. Now, SoundCloud obviously has black box probing. We even pay third-party services. They have probers all over the world, and they do probing. So what they do, they simulate a browser session, go to soundcloud.com, open a test profile. There's a test track on the profile, which then the probe plays. And if the MP3 data hits the automated probe, success, we are up, all is good. Okay, So now imagine this viral track is in an S3 bucket that just gets knocked out because millions of users want to listen to that track. I'm not saying that SoundCloud works exactly that way, it's just like a reasonable assumption. So that S3 bucket falls over, nobody can listen to that track, millions of people are sad. Our test track happens to be in a different S3 bucket, the test track is available, we think all is fine, we are green, 5 nines availability or something. So this is the problem, right? Your probe, it mimics real user interaction, but you can never be sure it is the real user interaction. While Whitebox monitoring, that's something where you actually measure every request. And a service in your microservice architecture that is in charge of retrieving MP3 data and doesn't get that MP3 data, that's clearly a symptom, that's a problem, and you can alert on it. Okay. So second, long tail latency matters. The odds are that most of you have listened to a talk in like the last 1 or 2 years where someone was telling you how important tail latency is in distributed systems, especially microservice architectures. Probably, right? I mean, they were all pretty popular, pretty nifty, and those talks are right. Tail latency matters a lot in distributed system. I usually have some caveats. I would like to add some comments to those talks because it's usually not that clear-cut, as they try to suggest, but you have to take into account. You want something like average is completely useless, median perhaps, but you want something like 99% latency, or 99.9% latency, or 99.99% latency, something, right? Okay, now imagine you want your 99% latency, that's pretty modest, and you have probes, right? And now you want to get the 99% latency off the last minute because you want to alert quickly, right? If your long tail latency is bad, you don't want to hear about it an hour later, you want to hear about it after a few minutes. So how to measure the 99% latency over the last 1 minute? How many probes do you have to send? Easy math, right? Approximately 100, probably more for better statistics, right? So sending 100 probes per minute, perhaps that's marginally okay, but we get into a problem where we think, okay, our monitoring our system should not consume the majority of our serving resources, right? Let's say ballpark number 1%. If I use 1% of my resources for monitoring, it's probably fine. Yeah, but if I use like 20% of my resources just for monitoring, perhaps not so good. So, lesson is, if you want tail latency over a short time frame, probes are really problematic. It's great for like your availability over the last 3 months, because over 3 months you send a lot of probes. You can calculate many nines. But for like 1 minute, that's bad. While your Whitebox monitoring can actually measure every single request and tell you exactly your 99% latency. Great stuff. Also, if you put both things together, there's a very nifty thing, because in a multi-tiered architecture, you have a front end and you have a back end. And essentially, if you have Whitebox monitoring in the front end can report the latency it sees from its back end. So this essentially means you are black box probing your back ends with real user traffic, right? That's also, it's a very important insight. You get this because you control the front end and the back end, right? It's like many people try to install something in the browser, some JavaScript, to find out what the users see, which is really good, because Whitebox monitoring has this inherent problem that you're essentially putting the fox in charge of the hen house, or how the saying goes. Like, you're essentially asking, how well are you doing? And the server says, I'm great, right? Could be lying to you. On the other hand, if a server says, I'm really bad, it's probably true, right? But then again, if you ask a service, how well is your backend doing, that's pretty valuable information. Okay. Final third reason, and this is like the perfect, like Paul's keynote is the perfect segue here. It was really valuable to hear about, okay, nothing has happened, now outage has happened, you still should have a postmortem and think about it. That's, of course, for real postmortems where something really happened, it's also good. You still need to investigate causes. So if your site is down, your black box probing tells you your site is down. So why is it down, right? So even if you don't want pages for causes, you want to know about causes. And that's when you need a monitoring system that has a lot of insight, because you want to know where's something going wrong. And your monitoring system should be time series based, so you can actually look backwards and see how did this look yesterday, or if you're in that postmortem session that Paul talked about and you have your chat ops log, you can also say, okay, let's check out how was actually my 99% latency of that little component during that moment when the people talked about something is going wrong, right? So really important, causes are still important, even if they should not wake you up. This last point is also, again, something, this is one of my favorite quotes from the Blue Book, because this is essentially the reason why Prometheus was created. We need monitoring systems that allow us to alert for high-level service objectives, but retain the granularity to inspect individual components as needed. So this is both, right? You have a number of existing, let's say, legacy monitoring systems that are really good in inspecting individual components. And you have another set of monitoring systems that are really good for service level objectives. But you need them like separately with completely different semantics. With something like Prometheus, let's say modern, next generation monitoring system, you get those things with the same semantics, in the same context, perhaps the same box. So this is really important. Okay, now, what makes Whitebox monitoring a dev concern? This is the connection we want to find here, right? We kind of realized how like black box probing is something the ops people do and the dev people are not concerned with that. So Whitebox monitoring, why is it a dev concern? The primary reason, obviously, is for Whitebox monitoring, you need to instrument code. And who instruments code? The developers, right? So this is really, really important. And it's often a like cultural shock for people who have never done this, for like devs that have never thought about monitoring. Suddenly they have to, which is good, because they should think about monitoring, like DevOps. If you already have like a DevOps approach, they probably have thought about monitoring. But it also encourages DevOps and it benefits from DevOps. Prometheus, incidentally, started as an instrumentation library. So the first idea when Prometheus was born was, how do I actually make it easy for developers to instrument code for metrics, right? And how do I guide them to have the right semantics? What would be a good data model? And then, of course, you need to collect those data. So the Prometheus server was created. Then you need to alert on it. And then you had an alert manager. And you want to collect other metrics. And then the whole ecosystem grew. So instrumentation of code is really important. Once you are over this culture shock, it's actually fairly easy. If you've used Statsd, I mean, Statsd is not that old, but kind of is aging in a way, but some people have used it. It's kind of well known. Statsd also uses instrumentation. It's kind of the same thing. If you look into the code, it looks really the same. And shameless plug for Prometheus, if you use a Prometheus client library, you don't actually have to use Prometheus, the monitoring system, because you can use all this data you get from your code with other systems. The exposition format is well documented, and there are a number of third-party systems who can understand it. The Prometheus client library usually has also like bridging code, so you could totally decide in the end, I don't want to use Prometheus, I want to stick with Graphite, and just put everything you have instrumented into Graphite. No problem at all. There are talks about this out there. I will also not go into details how to actually do code instrumentation, because there are talks out there by myself and by other people smarter than me. You can use Google to find it. It's kind of funny that Google is not just a source of inspiration for technology, it's also a search engine, and you can use it for those things. Okay, so also anecdotal evidence. SoundCloud, since Prometheus grew up at SoundCloud, is kind of the earliest adapter of Prometheus. And once we had those endpoints for metrics exposition in binaries, in no time, people would use it for other purposes as well. So it's meant for the Prometheus server to collect metrics, but like people just wrote little tools because they found out, it's actually interesting to get this number out of my binary. So yeah, it's really a good thing. So the effort is kind of low, and your devs make your ops happy if they're still separate teams, because they finally think about monitoring. But the devs also make themselves happy, because the metrics you have exposed by your binaries, they also help you developing something. And this is like, it's a classical slide I have in some of my talks. Of course, when we developed the Prometheus server, kind of like self-referencing. Of course, we instrumented the code, right? Because Prometheus should monitor itself. And since we were the monitoring people, we kind of had no problem and like put loads of instrumentation in there, which we also used during development. Like this is just an example. This laser pointer doesn't really work. Anyway, so like Prometheus has a chunk data model inside how the storage layer works, and then those chunks are acted upon, so they're operations, and so you count which type of operation happens how often, and take first derivative in your Prometheus server, and you get beautiful graphs, right? Like it's so you write some piece of software, and then you run it, and then you see it's like a heartbeat or something, right? Whatever. Body temperature. So you get all those curves and you understand how your software works. And when you realize, okay, why is that taking longer than expected? Or what's it actually doing now? Of course, you have all your classical methods, logging, debugging. But this is just an additional tool in your toolbox for debugging. And it seems you have to instrument anyway, because otherwise your ops people cannot have meaningful alerting. You also get this for free, essentially. So great stuff. You get lots of returns. Also, I have continuous deployment of my slides. So this is the version I just created half an hour ago. Perhaps you were in Jürgen's talk. Developer target performance analytics, right? So this talk started with how do we actually close the gap that developers develop something, then somebody puts it into production, and then they never know about the performance data in production, right? So now, if your developers instrument the code, they know the metrics that matter because they instrumented the code with those metrics, and they already know how to use them, and they know to interpret them. Ideally, through DevOps, they are all kind of connected anyway, but this is essentially closing the gap. And at SoundCloud, where people are really very radically doing you build it, you run it, this is just second nature. Like people deploy something, it's all fast with deploy pipeline and everything, and they just do like, let's say, deploy 1 or 2 Canary instances, and then especially with this Kubernetes Prometheus combo you might have heard about, you get automatically attached the ID of your build artifact, if it's a canary or not, and you can see this all in your metrics, and you can immediately see, okay, my canary is actually 10% faster or slower in this regard and everything, right? So it's perfect, and this is second nature to people at SoundCloud. They just deploy something or canary something and look at the curves, look at the metrics, and they can immediately get a feedback about performance in production, right? Okay, also like in Grafana, we can draw bars if you do a deployment. So you even see on those dashboards, we have them on wall screens. You see a bar, this is the deployment, you can immediately see a performance degradation or improvement or resource usage change. It all integrates quite nicely. True DevOps spirit. Okay, so much about monitoring for now. Let's talk about profiling, and let's talk about profiling in Go. As I said, this is the representative of the Google way. So first of all, profiling is nothing new, right? Google didn't invent it, Go didn't invent it. Every sufficiently evolved language has profiling tooling because it's just important, right? Go was perhaps special that you got it in 0.9 or whatever, and it already had a profiler built in, very readily accessible. And some people also claim Go had this raving success because the tooling was so great. And then perhaps you didn't think so because the tooling is not really shiny, but it's very valuable for your day-to-day work. You can totally notice this was created by people who work with large-scale systems all the time, right? For me, it was great to have this, and was certainly driving my adoption. Large scale, also, you see this in many aspects in Go. Large scale, not only for the things you serve, but also large scale as a number of developers. Like this radical simplicity of Go is annoying often because you don't have really features, but it helps so much if you have huge organization and many people and teams and the movement between teams, all those things. Okay, but I'm digressing. I'm fishing for something else. Profiling is nothing new. This is the package in the standard library that is the built-in profiling. It's called runtime, pprof, does CPU profiling, heap profiling, other profiling as well, but these are probably the most important one. All pretty old school. You use this package, you can create profiling, like profiles. But then there's another package, and that has hopefully my laser pointer works. I think it has given up. Well, this is just too much light on the screen, and also 3 screens. Anyway, so I can point. So this is the magic line. This is an so-called anonymous import, where you don't actually use the imported package directly. You only import for side effects. And the side effect is that the HTTP server you probably have in your microservice anyway. If not, you could just add it with a line of code. This HTTP server suddenly gets magically an additional endpoint for profiling. And that's also pretty googly that you have like HTTP endpoints for all kind of things. You can also see that in the Prometheus ecosystem, where like almost every binary has like a /status endpoint that gives you valuable status information, /config to show you the configuration, all those things. Also, Prometheus metrics are exposed with an HTTP endpoint /metrics, always the same idea. And now you get additional endpoints for profiling. Also endpoints for like Go routine, dumps, all those things are at your fingertips. Okay, so this is the next step here in the magic. This is what you do if you want to profile. Like you use Go, the kind of command line tool that also compiles and everything. Go tool pprof. And then the first one is a heap profile. The second one gives you a CPU profile. So you get the profiling data via that HTTP server from the running binary. Okay, then you shells out into like a command prompt, and you can save the data, explore the data. My favorite is just you hit in web, and then it opens your web browser and gives you an SVG file of your profiling data. Whoever did profiling knows how this looks like. SVG, perfectly zoomable, and you can find your bottlenecks and all those things, right? So far, still pretty old school. I mean, it's nicely and readily available, but yeah, nothing really new. So what makes that an ops concern? So the one important thing here is this magic line, this anonymous import, is essentially penalty-free. I mean, it's probably a tiny penalty. But what we do at SoundCloud, whenever we have a Go binary, or whenever we deploy Prometheus, or you download the Prometheus binary from GitHub, it has this magic line in it, and it will by default expose those profiling data in every production binary. Of course, you never should route user traffic to that endpoint, but this gives you the ability, when some binary in production misbehaves, let's profile it as it is, right? Like this is great forensics, immediate forensics. It's not even forensics because the patient is not dead yet. It's like the patient is still alive and you can investigate the patient. It's not like, oh, something is going wrong, perhaps you should compile with debug flags enabled and the profiling code in it, and then redeploy and then recreate the same situation, having the same problem and then profile, right? This is all, yeah, it's just there, right? Like the metrics are always there. You can just attach your profiler and profile the binary as it misbehaves in that moment. I mean, it's a bit similar to what you do with the JVM when you send a SIG quit, you get like a dump. Similar things are possible with the magic endpoints for Go routine dumps, but like this fully fledged profiling is really nice. And I'm not saying this is only possible in Go, it's just automatic, essentially. It's built into the language to have this. It's very natural. So, and this is clearly an ops concern, right? If I have a problem, my site is kind of performance is degraded, and I can just look at the place in the code where it's burning CPU or RAM or whatever. This is just great and nicely connects all those dev and ops things. Another aspect is also, and this is also very much related to Jürgen's talk, developers should see how their stuff behaves in production, right? And also, whatever they do when they do profiling during development, whatever they do is artificial. Here they can look at their binaries and do profiling with real production traffic. It's a bit similar to what I said about black box and white box monitoring, that your black box probes might not be reality. So you can look at binaries in the wild and profile them with the real production traffic without significant impact. Interestingly, I talked about nice tooling in Go. Go was actually chastised by some people that it didn't have a classical step-by-step debugger when it was launched. I developed Prometheus and hunted down many hard bugs, and I never even missed that debugger. It's also like in a concurrent modern program, like stopping a thread and then looking at it might already create some weird situation. So it's not actually what you what's easy in a multi-threaded program to do like step-by-step debugging. And with all those tools, profiling, of course, old-style logging as well, and the metrics we had and Go routine dumps, we could hunt down the bugs without even missing that debugger. So it's all there, ops and dev. Okay. Next, what would be next step, right? Now we do profiling, we can do profiling production, we have monitoring. Devs are also interested in monitoring and they profit from it. The ops anyway, we have meaningful alerting. But in a real complex distributed world, sometimes the problems are really only happening in the interaction between all those services, and that's where you want distributed tracing. So this is also a hot topic. I will not talk about this in this talk. I will just give you the pointer. You should also have distributed tracing always and everywhere, like Googlers do, right? So this is also something as an SRE is also second nature. Something weird happens. I can totally trace where all those requests are coming and going. And not by coincidence, you might have heard about the Cloud Native Computing Foundation, sub-foundation of the Linux Foundation, to like promote modern microservice, distributed, cloud native architectures. First project there was Kubernetes, then Prometheus. Third project, open tracing, which is a standard or specification or framework how to do distributed tracing. So it all makes sense and all plays nicely together. So this should also be something you want to have available all the time. Okay, let's go to my 3 take-home items. As you might have noticed, read that SRE book. Even if you're totally not doing SRE, like at SoundCloud, we are totally not doing SRE. We'll talk about that in the not too far future, how we don't do real SRE, but how we totally profit from SRE insights. So this is a really valuable read if you haven't done so. And then the P's, play with Prometheus, right? So if you haven't touched Prometheus yet, it's kind of, you cannot get around that if you have a large-scale microservice architecture, but even in smaller scales, we have a lot of happy users. So you should at least look at it. Perhaps you can, again, just gain some insights from it, but if you use it, even better. And then, again, P and B, profile and production. Perhaps something you haven't done so far. All right. So Prometheus webpage, and the other link is just a file in the GitHub repo where I link all my talks. So I will link the slides there in like 30 minutes or something. Also, there are other talks by myself that are all around this thing, but you can Google for talks, not by myself as well. Totally recommend it. We have a few minutes left. I was asking for having a microphone here for questions, but you can totally ask me anything, even if it's not about this philosophical thing. You had a Prometheus question you always wanted to ask. I'm here for you. Ich kann auch Hochdeutsch, so if you are shy to ask in English, I can understand you and repeat the question in English. Okay, thank you so far, and I'm open for questions. So, anything? Or do you all want to go home after this conference? Can't really see. If nobody dares to there's a question. Oh, it's really difficult to understand, even if it's German. A bit louder. Okay, got it. So the question is, profiling is all Go. How does that work in other languages? Like, obviously, JVM would be the gold standard of, and for a lot of languages. So I'm personally very familiar because I, like most of my development work in the last years was in the Prometheus ecosystem was all Go. Kind of, I'm a happy gopher, but this is in principle nothing that is Go specific. Like, I'm not sure, I cannot link you to the preferred toolkit for the JVM to do profiling, but it's definitely possible. I don't know what's the best thing is. I mean, I've done this. I mean, at Google, we did this all the time, this like profiling where some endpoint, but that was their tooling. So it should definitely be possible. And of course, you don't want a huge penalty. I'm not sure how possible possible that is. I would like it to be possible, but this is kind of more like an inspiration. Look for it, and definitely what I do all the time, if I do Java stuff, sig quit, get the dump, that's already half the way there. There's perhaps your...
So did we understand that correctly, that basically Prometheus is going to get the profile data out of the application? So it's not an endpoint like receiving synchronous information of the application, it's basically going and collecting the data.
Okay, so now the question was how is Prometheus getting the profiling data? So like Prometheus is metrics-based monitoring, and profiling is like completely separate in a way. I mean, these are like the two different aspects in the talk, right? Prometheus, metrics-based monitoring, profiling in production has nothing to do with each other, except that you should do both, and that Prometheus was developed with this approach of doing. Or whenever Prometheus server throws up, we use profiling to find out what's going on, right? And they both use endpoints. So the metrics endpoint is just metrics. You can't even look at it. It has a human readable output. The endpoint for profiling data is only machine readable, but this is really like getting to the endpoint, taking snapshots, where are you in the code, all those Go routines at that moment. So this is separate, but it's also something the runtime of your language has to figure out how to expose profiling data. And definitely, it's the tooling is there. Like it's just could be that they are proprietary or whatever, but it should definitely be possible to enable that with your preferred language. Okay, another question. So question was, what happens if I'm crazily instrumenting things? I instrument everything, and then I can't see what's actually going on in the code because there's too much instrumentation. Is there a thing like I have instrumented too heavily? In principle, of course, you can overdo anything. In my world, the instrumentation looks always pretty lightweight. Like you have something, it's really just like, you want to time that function, and you put in Python, it's really nice, you put a decorator on the function, and then it's timed in a histogram. Oh, you want to increment a counter, you have like served that HTTP request, it's a 503, you increment the 503 counter. It should really be single lines. Now, it could be quite complicated, I guess. You have to think about it. The other thing I would be worried about is if you overload your monitoring system, if you expose too much data, right? And the most prominent thing, you will hear this everywhere, and if you have an external monitoring provider, they will charge you for that, is cardinality. So how many different metrics do you actually expose? And like Prometheus encourages you to have high cardinality, but not too high. Like the usual thing that you do, if you have like hundreds of millions of users, you put a user ID and you want per user metrics, and then you have hundreds of millions of metrics, and that usually kills your monitoring system. So that's something you have it's more like on that dimension that you have to be really careful. And yeah, you should, of course, your code shouldn't look obfuscated. It should look pretty lightweight. Otherwise, you're probably doing something really special, or you should think about if you're doing the right thing. All right, another question. There is one question.
At the beginning of the talk, you said there's sometimes differences between SRE and DevOps. I'd be interested in a few examples.
So I think first of all, SRE was invented when there was no DevOps, right? And I actually had trouble. I started my job and people asked me, what are you doing? Are you like responding to search queries all the time? Like, you know so much, you probably do this, right? And you type really fast. No, I try to explain what I'm doing. My first response was, I can tell you what I do, but then I have to shoot you. But then this DevOps thing happened, and I thought, oh, this sounds like what I'm doing. Or not? And then I said, we are kind of doing DevOps. And then I realized, perhaps not. So my personal take is always like SRE tries to solve ops tasks with the methods of software development. Why DevOps, that's not what DevOps is concerned with. Like DevOps tries to connect the worlds of Dev and Ops, bring them closer together, or in the extreme case, even merge them, because in our modern world, it just doesn't work in the other way, right? But on the other hand, if you work at Google as an SRE, you are essentially the ops team, right? The developers are a completely separate thing. Of course, they kind of have all those concerns and ideas about each other, but the existence of SRE means the developers don't get a pager. I mean, they get a third level pager, whatever. The SREs get a pager. Like many things are where you think, this sounds totally like you have this old style ops team again. I mean, it's not old style because they use software development as their toolkit to solve their operational tasks. But it's kind of not directed towards this merge dev and ops and get nicely along with each other. I mean, surely you want to get nicely along with each other, but it's really like it's a very different beast. But this is kind of the take-home message, that you would still, despite being totally different in your direction, there are a lot of shared insights. Okay, any other questions? There's one more question. Okay, I have to listen more closely. Okay, question is, should we combine? Should we combine DevOps and SRE? Like I heard with the ING, people do like risk biz DevOps or something, right? We should do risk biz DevOps SRE. I don't know. I mean, I think everybody has to find their way, this is an interesting question. I think SRE Google style only works verbatim if you are as big as Google and if you also have a culture that is similar. Even other big companies work differently. Like Facebook, like at SRECon, this convention about SRE, like Facebook is a big player, Google is a big player, but they already do things quite differently. Like I personally believe that you have to take into account the culture of your company, the size of your company, and then you have to come up with a solution. And in an extreme way, you could say SRE is like a flavor of DevOps, a very extreme flavor, but I wouldn't even go that far. It's just, yeah, what I said in the beginning. You have to find your own way, but you should know the stories of others and learn from them. And DevOps is so broad, intentionally broad, because people have different stories and different culture and everything. Like it sounds horribly vague and not like useful, but my personal experience was that SoundCloud kind of, when they went bigger and bigger, they said, okay, we have a bunch of ex-Googlers, let's just ask them how they did it in their company, and let's do that, right? And then they noticed, no, that doesn't work at all. And then let's do it slightly different. It doesn't work either. And then at some point, you come up with something that fits your own size and culture set, but it's not obvious. You can just look at different organizations and look how they did it and learn from them. Okay, I think we are getting out of time. If there's no super urgent question, let's conclude the conference here. Thank you very much.